is that true? If I plug in a -1, yeah, they'll make that a +2. 1 over 3 plus 2 is 1/5. They have the point correct. Derivative. Limit as h goes to 0, f of a plus h. So I need this function with -1 plus h in for x, right? I'm running less on the board each time I do these problems, yeah? You guys following okay? All right. No, just let me know. 1 over 3 minus 2a plus h, so -1 plus h. That's the first part of the derivative numerator, minus function with a plugged in. So I'm going to plug in -1 directly. I know that's the 1/5 right here. They gave me the whole point this time. So minus 1/5 over h. We need to compute that limit. Again, as always, it's a 0 is 0. So we have to play some algebraic game to find the factor of h above so that we'll cancel with 1 below, and then we can compute this limit directly. So I think we had a case like this in chapter 2. Maybe not quite as complicated as this one. I think we gave it the same denominator, right? We combined the numerator into one denominator or something like that. This whole thing. Okay. So if we do that, let's just try that. The other one worked. Why shouldn't this one? Limit as h goes to 0. So then I need to give this one the factor of this silly thing. 3 minus 2 times -1 plus 8 needs to go here and here. And this one needs a 5 here and here, right? And then I can combine them together. So I'll have 5 over 5 times 3 minus 2 times -1 plus h. For you computer scientists out there, I know you're not worried about nested parentheses. Minus 3 minus 2 -1 plus h over, again, 5, 3 minus 2 -1 plus h. It's a bit burdensome to the eyes, but it's not that complicated to the mind, really. Everybody agree so far? Maybe I should put a parentheses here again. This is going to distribute, right? If we have to. Okay, so the top all has the same denominator now. We just need to combine the 5 with the negative this stuff, right? And then it'll be that expression over this over h. So what is it? 5 minus 3 is 2, right? You guys gonna follow this okay? -2 times -1 is 2, but it's negative because of this. So I have 5 minus 3 minus this 2. So that's all gone. 5 minus 3 minus 2 is 0. What do I have left above? -2h. Agreed? I just don't want to write another line. You guys can expand it all you want and figure it out. It's 2h. Agreed? -2h, which is 2h. If you don't believe me, just expand it out and you'll see it's 2h. All right, so now I have the limit, and there's our factor of h we were hoping for. So we have 2h above, very above, and then right below that we have 5, 3 minus 2, -1 plus h, over h. But this h here, I told you before, you can just push this down, and this would be sitting right here next to this, so I told you before. Or you can view it as, flip and multiply, and you see the h is going to be down here with this factor, correct? So now that h and this h cancel. You got one above and one sitting right here, ultimately, right? So this limit should now read, limit as h goes to 0 of 2 above over 5, 3 minus 2, -1 plus h. And now, if you let h go to 0, the bottom does not head towards 0. So you can plug it right in, right? It's continuous to that location, so you're fine. So if this h here goes to 0, you got to figure out what you have. The top's certainly a 2. And what's the bottom? Well, if this goes to 0, then this parenthesized portion heads towards -1. If that heads towards -1, then this product, -2 with that, is going to head close to 2. And then 3 plus that's going to head close to 5. And 5, right, something close to 5 times that 5 is going to be 25. So 2/25. Just plug it in, right? Just plug it in, 2/25. So now we know the slope of this curve, 1 over 3 minus 2x, at -1, at that one particular location, is a rise of a run of 2/25. Roger?
So the point tells us where, so the 1/5 represents the slope of the...
No, the 1/5 represents the height of that curve at -1. Just like over here, right? Over here, at 2, the function is 2, 1. That's that height right there. That's the height of 1.
So we find the slope of the curve, or we find the slope of the secant? I don't.
We find the slope of the tangent line. This is no longer secant. This is the tangent line. The tangent line, the slope of the tangent line is the slope of the curve.
So it doesn't matter to either way.
Either way, what? If I do what or what? What's the either?
Well, I mean, if we're looking for the same point, they both touch each other. It doesn't matter if it's secant line. I mean, it doesn't matter if it's the tangent line or the function line that's going past. As long as they meet at that point, we're finding the slope of that tangent line from that point where they meet.
Or what meets? The tangent line and the curve?
Yeah.
That's correct. And they are the same thing, by definition. We're using definition. Yep. They are giving you the location on the curve, 2, 1. They're giving you the location where you want to find the slope of the curve. And then our derivative definition here, limit of this, right? The limit of difference quotient is telling you that slope, 1/2. This line here has a 1/2 slope. But since that's the tangent line to the curve there, that is the slope of the curve as well.
That slope, that line's always going to have
1/2 slope.
A half slope, so wherever it touches at that point, a half slope for that function.
Correct.
So if it touched on like multiple spots, you can tell.
Not necessarily. It could hit this curve again, but not have the same slope. It has to hit in a special way. At this small location here, it has to intersect exactly once. Let's say this curve is slightly different. Let's say it curved up like this again. So it's going to intersect it again, but that's certainly not the slope of the curve there. This line would not represent the slope of the curve at this intersection.
Because it intersects, it just has to touch and go back down.
It just has to touch it. It just has to glance. We'll say glance. Not very mathematical. It has to glance the curve. And this is a direct intersection between two curves, between the line and the curve. This is a glancing intersection. Every derivative is a glancing intersection. Use that terminology. Right. Got that technique though? Combine the numerators, find that factor of h and cancel. Cornejo, is that right? Okay. Yeah, you guys are doing good so far then. Seems to be all right. I hear a lot of grumbling and huffing and puffing. I'm telling my children, remember to stop.
I'm just trying to, I'm just hanging in really tight.
Good man, hang in there.
So I'm taking another class.
Yeah, chemistry, you told me.
Yeah.
Foolish mortal, what were you thinking?
8 credits in 5 weeks.
Foolish, foolish. If you fail both of them, it's your own fault.
Well, after this summer, it's 12 credits in 10 weeks.
All right, a quick theorem. A quick.
Don't worry, just trying to pass all with C.
Quick rule about derivatives and continuity, then we'll move on to 3.2.